Right, so now what I'm trying is I took out one of my old Bedini solid state units where I had the trigger, which was the controller basically, and the trigger isolated on their own power supply here. The controller being around 40 mAs, and this other power supply here, 18 volts, charging this capacitor. And instead I noticed in the previous videos that pulsing the charged capacitor into the coil yield much better results. So I decided overnight to charge these capacitors here. So I had all these cells here connected overnight to the... What's something to note, folks, it's much easier to charge the capacitors or batteries at each capacitor or battery individually, like these supercapacitors, you know, like at 1.5 volt or so on each, instead of trying to bring up a charge of like 14 volts and then charging it at each end. So much easier to, like what I did is every capacitor had its own cell and it charged it fine, slowly but fine overnight. So this runs the controller here, and because they're super caps, you know, it runs the controller being about 40 milliamps. It runs for quite a few hours. And I've got two cells here which I'm using to charge this big capacitor, and I'm just observing the charge here. Once it gets to a volt or so, I'm going to try pulsing it and see if it can keep regauging itself and see what we get. So I will be back momentarily. Alright, still going it seems. We'll see if we can get more juice out of it here. Still waiting. It's been a few minutes here. As you see, it's climbing pretty good. Alright, so it's at about 1.4 now. So let's see if I could carefully turn this on here and pulse it and see if we get a reading in spikes and what that reading will be. And if it can sustain it at all, if it's going to plateau or go down or keep rising, who knows. Okay, there are those spikes. Let's auto set. So it's saying 25 volt spikes. 34, 38. So more than 50 volts. And let's watch the meter, see how it goes. See if we can find the sweet spot. Something happening there, I think. Oh, did I find a spot? So 0.570. And what are we getting on the scope here? Peaks of 4.4 volts. 4.8. Let's see if it's going to keep rising here. So I guess it's about finding the sweet spot here. I'm sorry, that's my dog dreaming. So the voltage is going up, and we're at 5 volts peaks now. So it's peaking at 5.2 now. So the concept is working anyways, and we're running at frequency 222 Hertz at 1%. All of a sudden it started to charge the capacitor up again, and we're still pulsing it. It's just the cells are able to re-gauge at this frequency. Slow uptick, but it seems to be happening. So what are we pulsing at now? 5. It's flickering a lot. 5 something. Let's see if we can adjust the frequency a little bit. That seems to be working on that position. Let's see what we're getting here. Now at this setting, 3.8, 3.9, 4. How's it going here? Still an increase. So now I'm at 326 Hertz, 1%. Well, that's a good sign that it's not going the other way. So what are we getting here now? 4.2 now. So the peaks are increasing naturally as the capacitor's charge is building up. So now 4.4, 4.5. All right, so still re-gauging pretty good. 0.63, 0.4, 0.640. And out here now we're getting 5.12 peaks. So let's see if this continues on. So far so good. And all of this is holding up. Yep. So all from the quantum power cell, which is pretty good. So this is what I mean by free energy, but not in the sense that it comes from nowhere, just that it's so efficient that we don't have to pay for it out of our own pocket, and you can keep recycling the process by that, starting it over and over again. 0.647. So it was about finding the sweet spot frequency there for a moment. I did it on the spot. The experiment was live. I had no idea what the conclusion was, no presets or nothing to make the video better. So that's the thing. I had no clue if it was going to work. So far we're at 5.6 now. 5.9. Not bad. And again, just these two cells here charging this capacitor, and we're pulsing the capacitor in the coil and just measuring the inductive kickback spike that we could charge like Bedini would do batteries or other things, capacitors, dump them. So that's good, a continuous rise there. And over here we're now 6 still. 6.4. Alright, so still rising. And now I'm getting peaks of 7.4. I had to change the scale a little bit. 7.4, 7.5. Wow. We're still going up. I bet with some engineering I could somehow feed this back. I know some people will ask. I'm just not quite there yet with these cells and the capacitor setup, but could be a possibility. Probably easier doing it this way than depending on traditional batteries to do it, right? Because of the self-regauging capabilities, as you observe, of these cells. So what are we getting now? 7.7. 7.9. Wow. 7, 8. There's 8. This is getting interesting. So folks, this is experimentation live on the spot. I don't know the outcome as much as you don't know it. Well, obviously I will once I convert the video and all that, but as it's happening now, this is all live. And I'm quite happy because it lines up pretty well with how I thought everything was going to work out here. But it's just sometimes what you have in your mind and how it happens in real life isn't always the way you... So now I saw 9, I think. 8 now. So it's still climbing there slowly, and we're still hovering at about 9 volts peaks over here. Still doing the same thing. Controller still running fine. Eventually, I guess I'm going to have to wrap this up, but I just want to show you for transparency what's going on here. And running it for long enough for you folks to see the trend of what it's doing. And this all comes from the quantum power cell, by the way, the solid state dry cells. I got 2 of them here. Charging this capacitor. That's the charge we're observing, the 0.69, and that's what's pulsing through the coil. Yeah, there it goes. Alright, so still working here, and we're getting peaks still at around about 8.6. And my point here is this is very unusual because of the self-regaging capabilities of the cells that are being pulsed. What's very unusual, you know, with this Bedini-like setup is usually the batteries that are being pulsed eventually lose energy naturally. In this case here, when you're doing it at the right frequency, it starts going back up and regaging itself and charging up while it's producing the extra energy through the back EMF here, in potential anyways. So I find this behavior very interesting, thanks to the regaging capabilities of the cells. But as you saw there, for a moment when I just turned it on, it went right near to 0 until I found the right frequency. So the right frequency with these cells pulse the whole setup anyway seems to make a big difference on how they can maintain their regaging capabilities. So just something to look out for if this is the sort of thing you guys would like to do down the line here. But I guess you see the point here. Frequency really matters when you start playing with these Bedini-like devices and Don Smiths and you name it, Tesla and one-wire systems. As much as I love them, this is why I hate it, because you really got to find that sweet spot, and sometimes it's a very narrow bandwidth. So I was able to fine-tune some more, 579 Hertz now, and it's almost back to 1 volt, and it's slowly climbing. I'm actually surprised that they can regauge at this speed. And I'm still getting good spikes over here. So I'm wondering if it's gonna, well, it should eventually get back to 1 volt here. But this is pretty cool because, you know, here's the input trigger, and instead of running out, it's charging itself back up, and it's not even connected to the output. So very unusual setup for Bedini. So can you picture your batteries that are being pulsed, that you're taking in this case we're loading it with the meter such as it is here. Actually no, going through the transistor, but it's not strong enough yet to damage it, so I don't need to do much. But the point is, we could eventually charge batteries with this. It's all about finding the right frequency. And as I was saying, it's like having your Bedini input batteries raise voltage as the Bedini is operating and charging another set of batteries, what I'm getting at. So very unusual behavior. Could definitely take advantage of this if I were to engineer it in the concept somehow here. Alright, so we're back up to over 1 volt now. So as you remember, as I initially turned it on, the short initially causes a drain, but it is coming back on its own. So you understand, if it was just the capacitor, once it shorts out, it wouldn't be continuously going up like this in voltage while it's being pulsed, which means shorted out continuously over and over again, a dead short, but still going up. This is what's going on. So we're getting peaks of 26 volts now. So that would be able to charge a 12-volt battery almost. It's holding pretty good there. Oh yeah, you could really hear that field. We're generating is strong, even as I get far away from it. We find the frequency, sometimes a resonant harmonic. So a few feet, not bad. Alright, just keeping you posted. Now I'm just trying various cell configurations with different compounds and mixes. Here I'm trying to test 2 electrodes the same again, but I added the electrolyte powder to the mix, trying to dry it out. I've made the copper oxide mix very thin to try and make wafers with it and layer it later on. Just testing different compound mixes here. I tried here, you know, with the copper oxide, but as close as I could. Here I actually have a capacitor dipped in there with solder to see if that's going to do anything, if I could charge the capacitor. Here 2 plates of solder coils. So I'm just waiting for all this to dry, and here I tried to make a plate with a metal on the bottom and a foil on the top, but I think I flung this one because it went right through, so I won't have my electrode contact. So I think I flung this one, but just showing you. So this is going to dry. It's already started. I did this last night, so hopefully testing various consistencies and materials. Alright, here's more information that I must point out. For traditional galvanic cells between 2 dissimilar metals, so if we're looking for that reaction, we're looking for the electron to the capability to basically donate electrons here. So there's in reference to hydrogen, here's that chart. So basically, if we make combinations of all of these, you see the electron reference to hydrogen here. And what we want to do is find 2 dissimilar metals with the most variant to create that potential difference. So it becomes a challenge of finding the right combination that has the most difference that wouldn't corrode. So basically we use the electrolyte, that's our ion bridge. It doesn't have to be electrically conductive, but you also need another system for the electrical electron conductivity. Typically the fluid, the water, is what facilitates in this sense. So the Zamboni pile and various dry cells that use a thin paper and the moisture in the air, this is the part that would facilitate, as bad as it is, the electron flow. Now, using other materials that are conductive but non-metals like graphite, carbon, and conductive polymers, as you can see, it gets very interesting. And the voltage will depend on other systems such as the electrolyte, the quantum tunneling, the electrostatic, and other systems that I've talked about instead of traditional electron flow. So maybe that's what originally confused people, because I didn't think that the carbon at first, you know, was non-metallic, and it isn't. So it doesn't have that same potential electron-wise, even though it does have a work force, so work function, I should say. And more interestingly, this is more of the same list here, but when you start playing with more exotic stuff like the barium and the lead and the quartz and the lithium and the zinc and the various oxides, you get, it's basically you're on your own. It's a whole different set of rules here. So just to show you that, I'll zoom out of here a bit so you can, sorry for the shaking here. Barium. So this explains it better than I could. So you can see with all these materials that you can get, indeed, especially when we're no longer depending on the traditional dissimilar metals and instead of quantum tunneling, these are candidates, possible candidates, because we're not depending on the same systems anymore. And these all have their exotic properties, as you can see. Again, I'm sorry about the shaking here because I just have this for my own reference on my wall. Now, if we're going to build the cells with solid state, you know, polymer and whatnot, and we're not using traditional electron flow, instead we got to base ourselves on the work function unit. So here's the list in work function, because if we're not depending on traditional electron flow, we got to look at the work function of the two dissimilars. So this gives you an idea of doing the same thing but work function based as well. And again, it all gets flunky when you start getting into these exotic minerals, the titanium, the oxides, the barium, the quartz, the polymers. The game changes depending on what you're squishing in between the cell. So I've tried to do some basic math here with using the magnesium plates and the graphene, the carbon, and that varies a little bit depending on, so give or take, right? So what I did here is I went, you know, 5.1 minus 3.66, which gives me 1.44, which is right on the button of what my cells without conditioning are doing. So basing on the EV unit instead, and that's the work function. So very important chart if you're trying to experiment with these and we're not depending on traditional electron flow. This becomes very important. And the mixtures, especially of these more rare ones here, make a big difference. And the polymers and all of that, and the crystals and the quartz and the dielectric properties, the electrode properties. But of course, if you want a hybrid, a little bit of both systems, feel free to work with the traditional electron donor system as well, if you can find a way, and there are, with the dry cells to minimize corrosion, and hybrid it with some of this stuff here, then we're really, there's so many possibilities here, folks, that it's like I'm stepping into a whole new realm here. And the possibilities, the combinations, they're vast. So just putting out the information out there and hope that it can be of use. And again, sorry of all my shaking, I really can't help that.